We'll be calling this the 2.C.4c homework. It's 9.44, 9.46, 9.48, 9.52, 9.54, 9.62, and 9.64. And these have to do with Lewis structures. So we have not only the regular Lewis structures, but also the exceptional Lewis structures come into play on this. 9.44 asked us to do the Lewis structures for all the molecules and ions. So OF2, remember, count the valence electrons, draw a skeleton, fill in with unshared pairs in the case of OF2. After filling in the unshared pairs and using up all of our valence electrons, which happens to be 20 valence electrons, we are able to do it without any double or triple bonding, and everybody gets an octet. N2F2 requires a double bond between the ends to make the number of electrons work for the molecule. Si2H6 works well without double or triple bonding. OH minus, remember the minus charge means an extra electron, so OH minus works like that. Okay, this ion here is a -1 ion, but it has two Lewis structures that are equivalent, one with the double bonded O here and one with the double bonded O there. And so, because of resonance, we should draw both Lewis structures and a double arrow in between. CH3, NH3 plus, this ion here. Everything works out fine with single bonds. Coming over here to 9.46, the peroxide O2 minus 2 ion works out with a single bond. It has a -2 charge, and both oxygens have -1 formal charge. On 9.46, you're supposed to give the Lewis structure and the formal charge. Carbide, C2 minus 2, has a triple bond, and each carbon has a -1 formal charge. The NO plus 1 ion has a triple bond. The nitrogen will have a 0 formal charge, and the oxygen a -1 or +1 formal charge. NH4 plus, the +1 formal charge is on the nitrogen. In 9.48, we were asked to point at the bonds, identify the bonds that were incorrect. This double bond between carbon and hydrogen is incorrect. This single bond between carbon and oxygen is incorrect. What it should look like is hydrogen with a single bond and the oxygen with a double bond. That will get the oxygen an octet and hydrogen a duet. Coming on over here to 9.52. We were asked to do all of the Lewis structures, all the resonance structures for chlorate, ClO3 minus 1. Now here's a case where to get the proper formal charges, to get the chlorines and oxygens as many as possible to have 0 formal charge, we do expand the octet of chlorine and give chlorine 10 electrons. But this actually improves the formal charges. So you end up with 3 Lewis structures, 3 resonance structures for chlorate. 9.54, we were supposed to draw both resonance structures for this molecule, CH2NN. One structure would have 2 double bonds. The other one would have a single bond between carbon and nitrogen and a triple bond between the nitrogens. I think I would actually prefer this one because this one puts a negative formal charge on carbon and a positive formal charge on nitrogen, and nitrogen is more electronegative, so that's kind of backwards as far as formal charge. 9.62 asked us to look at beryllium dichloride, BeCl2. This is another exceptional octet deficient example, because for BeCl2 to have good formal charges, you actually want the Bl to have only 4 electrons here. So that's going to be 2 minus 2 is 0, and chlorine 7 minus 1 minus 6 is 0. So actually we allow BeCl2 to be octet deficient. We don't like the double bonded, even though it does generate the octet for beryllium. It gives it a minus 2 formal charge, and beryllium has a very low electronegativity, so that would be not plausible. And the final one is SbCl5. SbCl5 is an example of an expanded octet. To get 5 chlorine single bonded around antimony, you have to have 10 electrons on the antimony, but that is allowable since antimony is in row 4, and rows 3, 4, and 5 are allowed to have expanded octets.